Hello, my name is Brian Kim. I am a grade 8 student attending BIS Canada, and for my BIS Canada science project, I've been working on neural networks. And after I have taken a look at all of the algorithms and produced successful about two of these algorithms that I have somehow planned out, I realized that neural networks is recommended to use at almost every part of our daily life somewhere in the near future. In my prediction, I think about a couple of years later, or maybe when I'm in college, since I'm a grade 8 student, I think artificial intelligence will be everywhere used in our world. Starting from modern day applications like medical diagnosis, people who use or somehow handle with big data usages, trying to analyze big data, trying to data mine them, economic predictions, business person supposed to use AIs right now because AI is a lot better at calculating profit and somehow simulating trade marketing systems right, other than humans, better than humans. Um, so basically, artificial intelligence is everywhere. It is like the Renaissance age of artificial intelligence. So it might be that someday artificial intelligence would be somehow a requirement for major computer programmers. So um, in this video, this is all about a tutorial about, since I'm a grade A student, I'm looking at the level of middle school or high school students who are willing to learn about neural networks. Um, in order to learn, in order to fully understand neural networks, you have to learn you have to learn math at a linear algebra level. For me, I am not. I am starting calculus. It is not close to me to basically understand everything. But however, due to my due to my successfulness of producing two algorithms that somehow work based on the morals of two neural network algorithms, I'm willing to give it a shot to give it a very easy, brief introduction for Kickstarters. So this is all about a tutorial that will somehow encourage many other people or many other middle school students to work on computer programming or to develop artificial intelligence for a new future because it's a lot of fun and it may be also useful. So let's go ahead and get started. Honestly, I've been looking at my previous recording and I realized that my voice is a little bit too hyper. Yeah, so let's get started. So in order to understand a neural network, you have to understand that it is very, very simple. The concept is simple. So it is biologically inspired, which basically tells you that neural networks is a program that is created by the inspiration of organisms. So in most organisms, especially I think all mammals, almost all mammals, um, they have a thing called a brain. So a brain is an organ that is made out of trillions or somehow, yeah, trillions of neurons or things called synapses. Um, Now these synapses are very simple. They transmit signals, electronic signals to other synapses, and they somehow creates this system that is very, very complex. So it is like this everything is about this guy named Alan Turing. He made this theorem saying that let's go with the zeros and ones, the binary theorem. So if you if you just put numbers that simply gets true or false, one or zero, and if you just label it in a significant pattern over and over again, you're gonna get complex patterns that can basically create modern day computers or modern day artificial intelligence. Synapses work out the somehow similar theory. So if more than one synapses, or if many synapses connect with each other in a complicated connection form, they're going to create complicated patterns, which will then further develop a system of potential that would solve complex problems. So if we go into the next slide, we're going to take a look at the synapses. There are a bunch of synapses structures right here, but the thing that we're going to focus on is the dendrite and the axon terminal. Or normally, most of it's located in the axon right here. You can see my mouse pointer pointing out. So the dendrite is basically the term where the dendrite receives all incoming electronic signals by other synapses. The incoming electronic signals, everything is combined with the nucleus. The nucleus somehow combines every electronic signal and interprets it by its own method of comprehension. And after that, it takes to the axon, sums it all up, and just somehow boop, sends it to the axon terminal. And the axon terminal spreads the combined electronic signal to other synapses, the same cloned electronic signal to other types of synapses in the system. It goes on and on. So this is another overview of a synapse. This is the transmission process of how the axon terminal, or somehow we call it the axon, sends a signal to another synapses of the dendrite, what we have seen previously. So we take a look at neurotransmitters, but this is nothing to explain. It just says we're going to send electronic signals because that's what a neural network does simply. So if we go back, we can see that a neural network is a similar structure to the synapses. We can see one, two neurons at some kind of another layer, and we can see 5 other neurons at the second layer, and there is only one only one neuron at another layer. So there we can see that there are 3 layers in total in this system. Further on, we're gonna take a look at how they're being worked as. So these lines, they represent connections. These connections, so if this is the axon terminal, then it's sending its electronic signal to these neurons. So in this case, this neuron is sending its signal to every part of this layer, every neuron in this layer. Same thing as here, and same thing as here, corresponding respectively. So, we're not going to learn anything about right now because this is just an introduction. So we're going to take a look at how are neural networks used. So there are many ways. So for the first thing is another method of optimization. So in computer programming, optimization is the key subject while working with algorithms or other sets of problems because we humans we think as fast and furious, right? Fast is better, and better means revolutionary, something like that. So how fast works is all about optimization in software terms, right? There is the bulky there is a bulky hardware where they do all the meat lifting. But however, the software is more extricate, and it needs optimization in order for the hardware to ease the burden of this hard-working load, right? So neural networks is another method of optimization. It can comprehend trillions of data faster than other common algorithms. So artificial intelligence is another reason why it is popular because of optimization. There is another thing called pattern recognition. This is some type of a Renaissance project stuff, because many interesting results are coming out while working with pattern recognition. So this is an example of what Google has created. So this is called a Google Dream Project, where Google has implemented a artificial intelligence system that can uh, dream certain types of images. So what the process works is that Google basically feeds the computer a bunch of images. In this case, it is a Japanese castle, I guess, and the computer analyzes the image, the common edges, the common color, and it just basically analyzes the Japanese castle. And then if the computer basically spits out whatever he analyzed, it gets these beautiful pictures somehow representing the dream of the computer. So this is just a representation of what the computer has analyzed in an image sequence form, but you can see it is all beautiful and all that. What you can see is that these edges, these castle-shaped edges, they are a type of pattern. And if you see the bigger picture, the castles are everywhere along this somehow mountain. There are trees. I think there are castles too. Oh wow! So there is this pattern going on everywhere in this picture. So pattern recognition is the most advanced technique that you can use in neural networks. And there is also big data analysis, which in this case, I want to tie it in with data predictions because it also works with economics. If you're a broker, you want to basically predict the graph of economic flow. Then then there's neural networks where it analyzes the current pattern and then somehow predicts it based on pattern recognition. Because a graph itself, it is a pattern, right? There must be a pattern in also economics. There's this book that basically says that there is always a pattern in economics. Very brief, but somehow like that. So method of optimization, there is pattern recognition, big data analysis, and data predictions. So that's what neural network is somehow overall used, and there are many more that can be used in neural networks. So let's look at the types of neural networks. We're going to take a look at backpropagation, genetic algorithms, and a thing called a particle swarm optimization. I think there are many more, such as I think it's the Boltzmann machine. But however, we're going to take a look at three categories. So, backpropagation, genetic algorithm, particle swarm optimization, they are all related into neural networks, this small system that we have seen in slide 4 right here. I must have edited the PPT, but sorry. So every backpropagation, every genetic algorithm, and almost every particle swarm optimization that relates with neural networks is all responsible with this business. So it uses this system, but however, backpropagation, genetic algorithms, and particle swarm optimization, they are three methods of trying to optimize the connections or the force of connections that these synapses somehow connect to each other. Simply put, they're trying to optimize the neural network system. So whether if one synapse should have a strong connection with one another synapses or something like that. So we're going to take a look at backpropagation and genetic algorithms as an example. And particle swarm optimization, I did not program that, so I cannot show it to you. But these two I did. So yeah, before that, these three algorithms, they're all with the purpose of trying to find the best optimum within this weird function or within the system of neural networks. So simply put, neural networks is used by certain types of problems. That's what a program does. So let's take a look at economic graphs, right? If a graph goes like this flowy curve, and you want your algorithm to predict what's going to go in at the from the end to the right side of the graph, then you're going to use either of these three algorithms to somehow optimize or to somehow change the synapse structure or the strength of the connections of each synapses in order to match the pattern or in order to recognize the pattern of this graph. So that's what you're trying to get through. Finally, the global minimum. That's normal what people say. So we're going to take a look at a couple of examples to see how this thing works. Where is it? So we're going to go into two of these algorithms that I have created. One is the backpropagation algorithm, and one is the genetic algorithms. But honestly, I can say that the genetic algorithms is more fun than the backpropagation because this is graphics and this is console application, right? So here's an arbitrary pattern that I've inputted. So it goes with an arbitrary pattern. So I've made a pattern that the first input sequence is totally random. It's just arbitrary. So it can be in any number. I've chosen the number 2. And the second input sequence is supposed to depend on the first input sequence, where the second number should be the product of the first number multiplied by 2. So simply put, it's just 2 and 4, right? Because it's 2 multiplied by 2 equals 4. 3 multiplied by 2 equals 6. 25 by 2, 50, 40, 80, you get the pattern. If these two input sequences follow the pattern, the computer has to output a number 1 or some number that's close to 1. If it is wrong, let's take a look. 98 to 865. This is wrong. You have to output a 0. So that is the whole pattern. So if you somehow run it, it's going to take a while. It did not. Okay, so we're going to take a look at the console and see how it goes. So there are a bunch of calculations. We're going to get over through this if you guys want, right? If you want this tutorial thing. So I did a testing sequence. So what this does is that there are a bunch of numbers at the input sequence. So this is what the computer somehow is trained with. The computer learns all of these numbers. But however, I'm going to focus on the testing sequence, where it is a totally different number, which proves that if the computer outputs the correct 1 or 0, that means the computer has learned the pattern, since these numbers are totally different and was never reviewed in the training sequence. So we're going to take a look at the testing sequence. So 89 to 900 we've got right here. It doesn't follow the pattern, so it should output close to 0. It is close to 0. I'm taking a look at if it's 0.5, then it's going to be 1. If it's less than 0.5, it's going to be 0. Never a neural network is perfect, right? So it is an approximation of how it will be. 55, 65, yes, it's incorrect. 60 to 120, yes, it is correct, so it is close to 1. 44 to 90, now this is somehow incorrect, but the computer doesn't seem to recognize this pattern. I'm going to explain to you why, but maybe later. 70 to 140, yes, this is correct. 99 to 178, yes, this is incorrect, right? If you multiply by 2, it's going to be 198. 55 to 110, yes, this is correct. So we can see that it follows the brief pattern, right? It's cool. So we're going to take a look at genetic algorithms, where the difference between genetic algorithms and a backpropagation algorithm is that backpropagation algorithms, they have a training sequence. We can say that backpropagation algorithms are supervised, or we somehow say that, oh, this is this, no, this is that. So we're teaching this guy hints, we're hinting it, we're giving the answer, and we're forcing the computer to basically understand the pattern. Genetic algorithms is a lot different. It is what we call a we can somehow call it as a self-learning algorithm, or we can call it as a reinforced learning algorithm. Um, reinforced learning, yeah, reinforced learning is where if a computer is doing a good job, right? You're giving them an award. So let's say if a 3-year-old kid solved a math problem correctly, we're gonna give him a treat. Let's say good boy, and we're gonna give him a chocolate, right? That's reinforced learning. If the guy does not solve the math correctly, we don't give him anything. Um, Self learning is just putting this guy with a bunch of input sequences and letting him just analyze everything. That's self learning. That's what we do as organisms and mammal creatures, right? We do not somehow learn anything, right? We instinctively learn, right? That's a part of our instincts, right? Genetic algorithms is a representation that how can instincts or random values can somehow manipulate into a successful organism, right? So we're going to take a look at a brief mouse and cheese simulation. So we're going to take a look at, in a second, or maybe a couple of seconds, I don't know. We're going to take a look at these mice. What they're doing is that the black ones are the mice, the red ones are the poison, and the yellow ones are the cheese. The main goal for these mice are to eat as much cheese as they can and to avoid as much poison as they can. Normally, genetic algorithms are inspired by Darwin's theorem, where the weak organisms die off and the more stronger or the more luckier genotypes of the species survive. That's the theory of evolution. They're being worked out the same way, where the mice somehow, if the mice eat a lot of cheese, those species are going to reproduce more at a better chance than the rats that do not, right? So then, as generations increase, the majority of the rats will somehow eat more cheese. But if there's a lot of poison, it's going to slow it down, so there is no correct representation of it. So I'm going to make fire. I'm going to decrease the fire. I'm going to decrease the amount of poison. I'm going to just increase the amount of cheese. So this is a brief representation of the rats. They first do not know how to move. They just do not know how to move. Some of them just are stagnant. And then here we go. They somehow learn how to move because of the successful alpha parents of the previous generation. So as you can see, they are now moving. Almost the majority of them are moving because they know now that moving is the key to success, right? Moving to eat cheese. At somehow generation 8 or 7, they now learn the concept of eating cheese. They now learn the concept that cheese is key. So as you can see, if you somehow tag one organism at your screen and somehow following along, it does not have it might not have a specific pattern except for the other ones. And as you can see, they somehow guide themselves to the location of the cheese somehow. And also, if you take a look at the majority of the species, you can classify them. So as you can see, this guy's rotating. Some are now also rotating also, but there's one mutation guy, and it's just cool to see how it goes, right? So on Generation 7, they get the concept of how cheese is, what cheese is, and they somehow eat a bunch of cheese right now. Right now, I can see that they're following some kind of a pattern, but I don't know. That's until Generation 9. If we take a look at this, we can see their progress. So their score, their total score was 130 at the first generation, but at their last attempt, their total score was 3,771, which is a marvelous feat of optimization, which that was our objective, to increase the maximum score. So, particle swarm optimization, I think I cannot share you everything because I cannot, copyrights and all of that. But why don't you take a look, search on Google about particle swarm optimization. It is cool also. Alright. So, this is the end of our presentation. How neural network works, and a very brief introduction of how they somehow work. After this video, if you are very interested, or if you are a little bit interested to learn about, first of all, backpropagation algorithms, or genetic algorithms, I'm going to choose. But if you want to learn them, just send me a comment or give me a like or try to subscribe in order for me to notify whether to make a video or to make a tutorial about backpropagation or genetic algorithms. So far, what I've shown is my program related to science fair. We're gonna try more if there are more videos to produce. But I can say that I've made this pattern, but with this program, you can just input random pattern sequences, random number pattern problems, and this program can solve it in a matter of seconds. Same as genetic algorithm. If you put more poison, the progress is gonna be slow, but eventually they're going to learn the concept of poison and cheese. So that's about it. If you like this video or tutorial, why don't you just give me a comment about it, see if you like it or not, and just give me a post or a comment, say that, whether if I was just start this neural network tutorial, right? A brief neural network tutorial for Kickstarters, not advanced, right? So, thank you for watching. This was Brian Kim, and I'll see you later.